Okay, so for the constructor that we selected with the full frame buffer, we'll need the rotation, which I'll explain in a second, the source clock, the MOSI pin, your chip select, and your data command pin, and your reset. So you can see here when I instantiated the object here, I was playing around with this number one type of buffer originally, but I switched to this one, the full frame buffer, and you see here I've instantiated that, just copying it from the from here. Just copy the constructor onto here and then plug in your the pins that you're going to use, plug them into the constructor. And this UHG2, this is this rotation, just saying whether you want to flip the display 180 degrees or not. Trying to remember where that is. Yeah, so back to the reference here. You can see here for rotation, you click on that. You select, if you want no rotation 90 degrees, 180, 270. You can just pick one of these parameters. Pick the first one. I want any rotation, so it's a UHG2 slash R0. And you can see that here. UHG2 R0 is the first parameter, so no rotation there. And then I was playing around with the well, basically you see next here, I've set up the UHF frequency change, and you saw in the video that it was outputting the UHF frequency. I didn't have it change because it was too hard to hold the display and try to change it on the simulator. But anyways, it was outputting it, and that's what I've set up here. So anytime UHF frequency change, well, let me get here. This chooses the how you set the font. So we've instantiated the object here, and I've called it my UHG2. And so then we're gonna call the different methods, and the first one is setting the font. So go back to your GitHub here, and then under font groups, click here. Then you get a whole list of different types of fonts you can choose from, and you just go in and find a font that you're happy with, and you can see here. The actual name is right here, U8, for this particular font. It's not the one I used. But if you were going to use this Courier B08 type font, then you would just come down and copy this UHG2 slash font Courier, B08 slash TN, and then you insert that up, when we call this set font function, from my UHG2 object. We call that, then we just paste that into here as a parameter, and then it'll use that font. What was I using? I guess I used the I was using this UHG2 font 7x13B TF, because that was kind of matching the closest to the DED look. I had to go through a whole bunch of them, try to find one that looked, kind of matched it. It matched it kind of close. That's why I used that one, just imitating the D, trying to imitate the DED. Anyway, so you set the font, and then I called the drawstring function, and it takes the parameters of your x, your x and y coordinates. So your x is going to be where the display is going to start horizontally left to right, and then your Y coordinate will be where the column is printed out, vertically. If you're using, well, you can see I got UHF is on the X is set to 0, so it's, to the far left, and then it's the first row. And then you can experiment around with the different parameters on that function, for placement, shifting it over to the right, shifting it up and down, wherever you want to put it. You can customize it to your own desire. And so that's what I had basically had printed out, have UHF printed out permanently, with this drawstring function. And then the next one, I shifted down and had the actual value that's coming in, from your from DCS BIOS, in this case the UHF frequency, the string here, and had it. I placed it here, basically on the same line vertically, but over to displaced to the X to the right. Um, So UHF would stay permanently, and then this would change as DCS BIOS pumps in the different data. But I selected it, moved it over to the right with the X parameter. Anyways, that's pretty simple there. And like I said, that U8 library makes it really simple for you. And then the last function is the sending the string to the display. And I just started using this library, so I'm no expert in any way. But this one actually worked for me. I was using another method, um, which I have down here, right here, was using the first page and then a do while loop, and where you set the font, draw strings. And here's experimenting with the look, to set up, the look of a DED display, even though I couldn't find all the different parameters, like steer points and stuff like that. Obviously there's no F16 right now, so you're just playing around with stuff, trying to imitate it. But see on my other video here, trying to see if think it'll show. Yeah, this is when I'm initiating the display, and you can see there I was playing around trying to get the DED look, with the fonts and the placement of the strings and all that. So that is what this is right here. But this doesn't, I couldn't get this to work with DCS BIOS. All it would do is I can send out whatever I want, draw a string on the display, but it wouldn't update as DCS BIOS, would send data. So I just don't know how to use this method properly. So I just use, like I said, as initiation. And you can see here well, let me go back to where I was. I'm getting a little ahead of myself. Anyways, using this, setting the font, calling out function, then calling a drawstring function, and then sending it to the buffer. This worked good, and so that's what I ended up using. And I did another. This is the jammer, the line from the jammer part here, where it was actually showing it worked. I was clicking on the jammer button there on the A10, and you can see it changing in the display. So there was lifetime update of the data, and that's what this one, yeah, that's what this bit of code was. So I was just drawing the string, and and then sending it to the buffer, and this would constantly update every time there was a change in the jammer string. DCS BIOS will send the change, and then it was updating on the display. And then I got just setting up the general purpose input output pins and the MOSI and the source clock, chip select, and data command. And then this is pin 13 is where I had the LED connected. Just for the troubleshooting testing. They have those all set as outputs. And then I'm calling that begin function, that was up here in the GitHub. That basically would, this function here that initiates the display for you, resets the display. So I call that function, and then it'll draw that, it'll draw the DED imitation display. Then it'll delay for 2 seconds. Then here's where I'm sending the LED, having it go high and then low, and then clearing the display. So, this whole sequence here, you can see it right here in this video. And you can see it's flashing, so then it comes up with a display, and then the LED will blink once, and then it'll clear the display. I think I did a reset here. Yeah, reset itself again. So see, it's doing it over again, another reset, and then blinking the LED, and then clearing out the display. So so you can see that here. When it's displaying the page here, there's a delay. Then the display blinks, and then here I called the clear display function. From the object, and it clears out the display, setting it up, ready to receive data. And basically that's it for the Arduino programming part of it. And I think I've covered most everything. Covered the setting up the pins, how to wire up the display properly, and then went over the actual Arduino code to get DCS BIOS to send the data to the display. So I think I got covered most everything, and hopefully one day we'll get to use this in an F16 and DCS. We'll see. See ya.